Hello and welcome to this video. We are going to solve the exercise, Exfiltrating sensitive data via server-side prototype pollution. In the video description you will find a link to a write-up. The write-up contains more detailed descriptions. So if you have any questions, just have a look in the write-up. After starting the exercise, the shop should look similar to the one in the video. First, we log into the shop with our credentials Wiener and Peter. To do this, we click on the My Account link and fill out the registration form. After successfully logging in, we have access to our billing and shipping address. Here, we change the content of line 1 from Wiener HQ to Hacker and Victim Incorporated. We submit the form by clicking on the Submit button. In the next step, we switch to burp proxy and open the HTTP history there. In the HTTP history, we search for the request post/myaccount/change-address and send this request to the repeater. We see that when the form is submitted, the data from the fields is sent to the server as JSON. We add a new property to the JSON called proto, which contains an object with a JSON spaces property. After sending, we see in the response section that our proto property appears in the body. Our attempt at prototype pollution was therefore successful. In our browser, we see a link with the name Admin Panel. When we open this link, we are taken to a page where there is a button called Run Maintenance Jobs. If we click on this button, we receive the following information. Apparently, we use the button to start some jobs on the backend. This is a classic example of a function that can create child node processes. Let's now try to infect the prototype with a malicious child_process.execSync property that triggers interaction with the public burp collaborator server. We now switch to burp repeater and add the following property to our JSON. Make sure that you enter your collaborator ID. To do this, open the collaborator and click on the Copy to Clipboard button. We now send the request and switch to our browser. If we now click the Run Maintenance Jobs button again, we see that the jobs are no longer working. Now we open our burp collaborator and see that we have received DNS and HTTP messages. The DNS interactions confirm the execution of remote code. Now, in burp repeater, let's change the payload in our malicious input parameter to a command that passes the contents of Carlos' home directory to the public burp collaborator server. After sending the request, we switch to our browser, refresh the admin panel, and click the Run Maintenance Jobs button again. Now we see that all jobs have failed during execution. Now we switch to burp collaborator and see that we have received DNS and HTTP messages again. This time, however, we see a post request with a base64 encoded body. We now open the burp decoder and encode the base64 encoded body. To do this, we select base64 in the decode as drop-down field. In the lower text field, we then see the output node_apps and secret. We will now modify the command ls/home/Carlos so that we can extract the contents from secret. The command cat is useful for this purpose. After sending the request, we switch to our browser, refresh the admin panel, and click the Run Maintenance Jobs button again. Now we see that all jobs have failed during execution. Now we switch to Burp Collaborator and see that we have received DNS and HTTP messages again. This time, however, we see a post request with a base64 encoded body. We now open the Burp decoder and decode the base64 encoded body. To do this, we select base64 from the decode as drop-down field. Now let's switch back to our browser and click on the Submit Solution button. In the window that appears, we paste our base64 decoded code and click OK. This completes the final exercise in the prototype pollution section.